Teacher program. I don't hear you.
Visit numberrock.com for ad-free videos, lesson materials, and more.
If you split the number 1 into 10 parts, that's where the decimal place values start. The values less than 1, they're quite small, like 0.1, which is a decimal, y'all. This number as a fraction is 1 over 10, and 0.1 is its decimal equivalent. Fractions over 10, 100, 1000, and on are all decimal numbers, it's a phenomenon. Decimals are fractions, just with different names. They each have a value that's exactly the same. Whole numbers to the left, decimals to the right. They get smaller and smaller till they're barely inside. Like whole numbers can get big, decimals can get small. If you know place value, you can imagine them all. On a place value chart, you see a pattern starts. If you split 1/10 into 10 equal parts, this new value is 100th, and in every case 100 hundredths equals 1 whole in the ones place. And if you split just 100th into 10 parts, that's the next place on the place value chart. This value is 1,000th of the number 1. Like every decimal, it's a special fraction. When any denominator is a power of 10, that fraction can be written as its decimal equivalent. Whole numbers to the left, decimals to the right. They get smaller and smaller till they're barely inside. Like whole numbers can get big, decimals can get small. If you know place value, you can imagine them all.
We got the tenths, the hundreds, the thousands, and more. Let's imagine a number line to further explore. You see, there's a special land between 0 and 1, where you find decimal numbers in every fraction. Between 0 and 1, make 10 intervals. These are tenths written as fractions or decimals. When counting by tenths, after you get to 9, the 10th tenth makes 1 whole on the number line. Let's see what happens as the place value decreases, and 1/10 is divided into 10 equal pieces. We get 100th, and that's 0.01, and 10 of these make a 10, but we're not done. Split 100th into 10 parts, and we'll get 1,000, the smallest value we've seen yet. 10,000s makes 100th, 100 makes 1/10, 1,000 thousands makes 1 whole. Isn't it brilliant?
Whole numbers to the left, decimals to the right. They get smaller and smaller till they're barely inside. Like whole numbers can get big, decimals can get small. If you know place value, you can imagine them all.
Teacher program. teacher ไม่ของ teacher พังอ้าว
I don't hear you teacher Pelham
teacher ให้ชะฮึชะจุดนุบจุดI can not hear
เจ้าพอดเทียเจ้าเทียนทีจากเบสบอลที่ถล่มเดี๋ยววันนี้เขาจะใช้พอด
ไม่
เยอะ
ได้
ๆพอดทริปเทียนทีไม่นายคือเทียนทีนายจะต้องทำตามคำสั่งฉันนายจะต้องไประเบิดคนอื่น
ไม่มีทางหรอกตัน
ไม่นายต้องไประเบิดคนอื่น
ไม่เขาจะระเบิดตันนี่แหละ
ครับวิชาต่อไปดิเชอร์เข้าตั้ง10 นาทีแล้วครับแมทคลาสเดี๋ยวนี้
ว้าว
เอาละครับ
โอ้พอดฉันจะใช้แกเป็นเทียนทีนายจะต้องไประเบิด
เป็นไส้ศึกคอยดู
ไม่
เถ
ใช่
อะ
ของเอง
รู้
เทีย
จั
น
กเหรอ
ทีนะ
นอนบนไส้นอนบนไส้
เข้าหรือยัง
เข้าแล้วครับเอ้ยไม่ฆ่าคนนี่
ลาฉันลาเธออยู่แต่ไม่รู้คนใด เธอได้ยินเราไหม
โอ้พอด
อะไร
เอ้ยจะต้องไประเบิดตา
พี่เชื่อก็เปิดไมค์แล้วทำไมไม่ได้ยิน มันไม่ได้ยินอ่ะ
เปิดไปแล้วไม่ได้ยินเลยอ่ะ
ดูถ้าไมค์ที่เชื่อพังอ่ะแล้วที่เชื่อไม่รู้ตัวด้วยซ้ำว่าไมค์พัง
ไม่ได้ยินเลยอ่ะเชื่อได้แค่
ที่เชื่อพูดภาษามืออยู่ฮึดมีใครเข้าใจบ้างไหม
ลองสาบายอยู่ก่อนนะ
นี่เขาบอก1นะ แล้วก็บอก10 ส่วนมั้ง
เขาปิดใหม่แหละ
ครับ
Are you hear me
yes
Teacher, I can hear you.
only teacher Pelham
ใช่ผมยังไม่ได้ยินที่เชื่อเลย ผมได้ยินเสียงต่างๆแล้วผมก็คุยกับผมที่เชื่อได้ยินเราไหมที่เชื่อ I cannot hear
Okay. Is it better now? Can you hear me? Can you hear me now?
yes
Sorry. Sorry, sir. I don't know what went wrong. I'm talking, and I see you guys also talking and nothing happening. Okay, good. We are back. Sorry for that. I apologize. Let's quickly go. Could you hear the video?
I think new video
Okay, let's watch the video again because it was a good video to watch. Sorry. I can't believe it didn't work. Now? Better.
Visit numberrock.com for ad-free videos, lesson materials, and more.
If you split the number 1 into 10 parts, that's where the decimal place value start. The values less than 1, they're quite small, like 0.1, which is a decimal, y'all. This number as a fraction is 1 over 10, and 0.1 is its decimal equivalent. Fractions over 10, 100, 1000, and on are all decimal numbers, it's a phenomenon. Decimals are fractions, just with different names. They each have a value that's exactly the same. Whole numbers to the left, decimals to the right. They get smaller and smaller till they're barely inside. Like whole numbers can get big, decimals can get small. If you know place value, you can imagine them all. On a place value chart, you'll see a pattern starts. If you split 1/10 into 10 equal parts, this new value is 100th, and in every case, 100 hundredths equals 1 whole in the ones place. And if you split just 100th into 10 parts, that's the next place on the place value chart. This value is 1,000th of the number 1. Like every decimal, it's a special fraction. When any denominator is a power of 10, that fraction can be written as its decimal equivalent. Whole numbers to the left, decimals to the right. They get smaller and smaller till they're barely inside. Like whole numbers can get big, decimals can get small. If you know place value, you can imagine them all.
We got the tenths, the hundreds, the thousands, and more. Let's imagine a number line to further explore. You see, there's a special land between 0 and 1 where you find decimal numbers. In every fraction between 0 and 1, make 10 intervals. These are tenths written as fractions or decimals. When counting by tenths, after you get to 9, the 10th tenth makes 1 whole on the number line. Let's see what happens as the place value decreases. And 1/10 is divided into 10 equal pieces. We get 100th written as 0.01. And 10 of these make a 10th, but we're not done. Split 100th into 10 parts, and we'll get 1,000, the smallest value we've seen yet. 10,000ths makes 100th. 100 makes 1/10. 1,000 thousandths makes 1 whole. Isn't it brilliant?
Whole numbers to the left, decimals to the right. They get smaller and smaller till they're barely inside. Like whole numbers can get big, decimals can get small. If you know place value, you can imagine them all.
Perfect. Stop. Okay, yes, now we're back. Sorry for that. That was just a short video about the place values that we also talked about yesterday. Now, I wanted to show the video just because it also has to do with our lesson moving forward. So if we go back, we did the vocabulary. First things first, we had the whole numbers, where everything to the left is a whole number, like 10 is a whole number. A decimal is defined by the decimal point. And numbers to the right of the decimal point equals 6. No, equals decimals. The number in the example is 6, yes, but it means decimals. Convert means we have to convert from fraction to decimal. We will do that in the future. And between is in between two numbers. We have 1, 2 in between. So those ones we've done. Ascending and descending order. Who can tell me what is ascending order? Who knows? What is ascending order? Well, ascending order, if you look at this example, we gave numbers 1, 5, 2, 9, 3, 4, 7. So this is a random few numbers. Now, if they ask you to arrange in ascending order, what arrange means is to move the numbers around. Move them around to ascending order. Now, ascending order means going up, going up. So we start at the bottom with the smallest number at the bottom. And as we go up, 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 the numbers become bigger. They become bigger. So if I want to write the numbers on top here in ascending order, I will write them in the following: 1, 2, 4, 5, 7, 9. Meaning the numbers start small and go up. But what if I take the same numbers here and I put 1, 5, 2, 9, 4, 7. And they ask me to write it in descending order. Or in descending order. Descending means descent, meaning decline, meaning go down. D for down. So we start at the top with a big number. And then as we go down, 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 the numbers become small. So for this example, if we had to write the numbers in a descending order, we will have 9, 7, 5, 4, 2, 1. So that's the difference between ascending, going up, and descending, coming down. Down and up. So up, ascend, down, descend. Okay. Very basic. Now, if you look at a small part, let's quickly look at some part in the book, because we have to use the book in some explanation. So, look at our first block at the top here. It says the colored part is 4 out of 10 equal parts. So, it says it's 4 out of 10. Now, in fractions, we learned 4 out of 10 equals 4 over 10. But if we divide the 4 divided by 10, like we would do to convert it, how many zeros do we have for 10? You can tell me. How many zeros does 10 have? How many zeros does 10 have? Who can tell me? 10 has 1 0. Okay, anyone with me here? 10 has 1 0. So if you have numbers that can be divided by 1, 10, 100, 1,000, 10,000, 100,000, it's very easy. You take the amount of zeros and you add them in front. So from the 4, after the 4, we have the decimal point. We move 1 point to put the decimal in front. 0.4. What is the answer of 40 out of 100? Let's see. 40 over 100 as a fraction also equals, when we simplify it, divide 10 to give us 4 out of 10. So the answer will be the same. And if you look here, it shows us all our answers are the same. 0.4, 0.40, 0.400. It doesn't matter how many zeros you put at the back of the decimal. It will not change the number. It will not change the number. So yes, right. Let's see what, who is writing here? Is Tantan writing here? Let's see. At the bottom for the examples, write the 1 decimal digit that is equivalent to the decimal given. 2.3, yes. 1.9, yes. So here, 0.90 is exactly the same as 0.9. 2.300 is also same as 2.3. If you add a 0 to the end, like here and here, of a decimal, it will not change the value. It will be the same value. 19 as a decimal is 19.0, but this one is correct. What about 0.6? If you write 2 decimal digits, 0.60, this will be 7.30, 2 decimal, 7.30. So this one is incorrect. This one, 8.00 will be correct. 8.00 will be correct. So 1 decimal place, 1. 2 decimal digits, 2. What about 3 decimal units? 6.80 will be 6.800. Now 6.8 means exactly the same as 6.8000000. The value doesn't change. When you add a 0 before the decimal point, yes, then it changes to 6 million. So they ask us for 3 decimal digits. So we after the decimal point, after it, put 3 numbers. The second one, 6.970, 3 digit. And what about the last one? Who can do the last one? What will 25.0 be? Give me 3 decimal digits for the last one at the bottom here. Who can do that for me? Or who wants to say the answer? Who can tell me what is the answer for number 3 here? Anyone? 25 point 000. 25.000. That correct? Yes, that is correct. Okay. Let's look at the bottom. Now I want you guys to answer these questions because I don't want to talk all day. Write true or false in each. Number 1. Is it true or false? Number 1. True or false? Anyone? Give me an answer. True or false? Let me hear an answer. Must I call someone's name? Or will someone answer? True or false? Is 0.8 equals to 0.800? True or false?
False. True.
True. It is true because no matter how many zeros at the back of the decimal, the number does not change. True. True. Number 2, 3.4 equals 34.00. True or false? .4 equals 34.00. True or false? Are they the same? True or false? Number 2. Someone give me an answer. What do you think, Jasmine? True or false? Is the 3.4 equal to 34.00?
False.
False. Yes, very good. It's false. Why? Because look at the decimal point. 3.4. This one is 34 point. So this one is larger. It's larger. False. Is false. What about number 3? 39.00 equals 39. True or false? I'm going to ask who's going to answer now. Who wants to answer this one? Or should I call someone? How about Do you know? Do you know? Number 3, true or false? Or someone take a guess, take a guess. Yeah, you have one of 2 options, true or false.
True.
False. Why do you think it's false? Why do you think it's false? Let's look at the decimal point. Let's look at the decimal point. So this one's decimal point is after the 9. This one does not have a decimal point. But where would the decimal point be? After the 9. So 39.00 equals 39. That is true. That is true. The number is the same. And number 4, 95.67 equals 95.670. True or false? True or false? This one is true because all they did was add 1 0. Now at the end of the decimal. But if we add 1 0 at the end of the decimal, the value does not change. It stays the same. Okay, it's important to remember that. Value stays the same. Number 5, here top, comparing decimals. Now this is something that I want to create a little worksheet on for us to do. If we look at the top, we have 3 signs that we work with. Where's my whiteboard? We have 3 signs that we work with. Can anyone tell me what do we call these signs? What is the first one? What do we call this sign here? The first one. What does it mean? Who knows? Who knows what it means? If we look at 2 numbers, 2 different numbers, we want to know which one is bigger or smaller. We use one of these 3 signs. What does the first one mean? Who knows? The first one means greater than. Greater than. For an example, we have 5 is greater than 4. 5 is greater than 4. If this one is greater than, what is this one? What do we call this one then? Start with the first letter. Okay, here we go. Let's see, you can, if teacher can beat you.
These are, I think, is smaller than.
Thank you for answering. Smaller. Okay, let me erase it. Smaller than. Smaller than. And for an example, Oops. For an example, we can say
I think equal.
4 is smaller than 5. 4 is smaller than 5. Now, let's look at how will we remember this? How will we remember and keep it inside to know? If you see this big mouth coming at you, like this, coming to eat you, you better run. The big boy is coming. The big one is coming to eat you. Now, the way the mouth is pointing, if the mouth is pointing this way, then this number is bigger. Because if you look at the end, if you look at the structure here, it's small. Here, it's big. So the way the mouth is pointing to tells you which number is bigger. Bigger. Doesn't go up or down, only sideways. So this one, the number on the right hand side is bigger because that's where the big mouth is. And the small part at the end on the left is the smaller number, like we can see. Okay, the last one is very easy. It means just equals to. And for an example, 5 equals 5. 5 equals 5. Okay. I want to leave you with this for today. I know we don't have a lot of time left, and we had some audio issues, but that's fine. I want to leave you with this for today because this is very important to know. Where the mouth is bigger, the other side is smaller. So like this, the number this side is bigger. The number this side is small. Because look at the space I have here, my fingers here. Look how big this space is. And look how small the space at the back is, very small. So that's important to know because the next lesson, we will do questions on this and examples. And I want all of us to participate. So this is one of the most important things when we do what? When we are comparing numbers. When we are comparing numbers. Whenever you read the word comparing numbers, the first thing you should think of is these three signs. Greater than, smaller than, equals to. Greater than, smaller than, equals to. Okay. Only have 1 minute left for this class. I will remake the video. No, I won't remake it. We will carry on next week. Not next week. When do we have class again? On Friday. We carry on Friday. Okay. I don't think we have time for rock, paper, scissors. So we'll have to do it tomorrow. Okay. But thank you all for coming today. I hope you have an amazing day. And I will speak to you again tomorrow morning, nice and early. Have a good day. Bye-bye.
Bye bye. Bye bye.
Bye bye.